Okay, your responses are of paramount importance. If we are to go ahead with the class, please kindly respond. I'm not going to be, it's pointless if I just go on alone as if I'm just playing a record.
Yes, we can see your screen.
Okay, so for today, we want to focus mainly on the calculations. So we are going to be focusing mainly on the calculations. So I the detailed theoretical aspects. I'm going to be sending recordings from the previous sessions on this, but the main reason for this lesson is to assist you, especially in the areas that are difficult to just follow through in the recordings. The module is quite long and we don't have time. The module is quite long and we don't have time. And also the other complexity is that is from the concerns that most of you raised, it's difficult. Okay, Standazile, you are saying you can hear, but you can't see the screen. Not knowing if there is also anyone who is affected. If you are all able to see my screen, it could mean Standazile is your network. So you may try to refresh from your side because if others are seeing and it's only you, it could be your network. So I will start, maybe let me start from chapter 5, probability distributions. So how am I going to be working through today? We'll just be focusing mainly on the calculations. So I'll go through an explanation of the example, then we do a question. Go through an example, I'll just go through the example, then we do a question. So for detailed explanations, you can use the recordings that I have already sent before. So for this session, like I said, it's just to help you through with the calculations part. So we have the first example, 5.3. We're given what we call a probability distribution table. So for a probability distribution table, the first question here is saying find the value of A. So if you are calculating the value of A, let's first of all understand what the table is saying. So the table is saying that the probability that X is 0 is 0.05. So below are the probabilities here. So we're saying what is the probability that X is 0, 0.05. What is the probability that X is 1, 0.35. What is the probability that X is 2 is 0.5. What is the probability that X is 3 is A. The probability that X is 4 is 0.02. So below are the probabilities. So what are we supposed to use to get the value of A? So we are going to start with probability distributions. So probability distributions. So all probabilities add up to 1. It's a common rule that I'm sure you all know. All probabilities add up to 1. So for those that joined recently, please let me know. I will resend the recordings of what was covered before. And also, what I'm going to do, I'm going to send all recordings for the topics ahead so that you can read ahead, practice ahead. So when we get chance for a live session, I'll be just touching on the calculations, but most of the stuff you have done it. So all probabilities add up to 1. So the question is saying that what is the value of A? So from that knowledge that all probabilities add up to 1. So you're going to add the probabilities of 0, 1, 2, 3, and 4, and you equate that to 1. So we're saying 0.05 plus 0.3 plus 0.5 plus A plus 0.02 should give you 1. Why am I getting that? Because we know all probabilities add up to 1. So that's what they did here. So they're using the general rule that if you add up these probabilities, they should give you 1. So you form an equation. So 0.05 plus 0.035 plus 0.5 plus A plus 0.02 should give you 1. Then if you make A the subject, this gives you the value of A as 0.08. So that's how you work out the unknown value there in a probability distribution table. You add all probabilities, you equate to 1. So with that in mind, we can even calculate for activity 5.1. I would have loved to give you an opportunity to also work some of the questions out, but because of time, I will be doing it. But I would prefer if you can work along with me and also assist out with some of the answers. So I will just do question number 2. The probability distribution of a random variable table is a variable is tabulated below. What is the value of P? So remember the golden rule is all probabilities, they add up to 1. So we're going to take the probability. So this is activity. Let's check which activity was this. It's activity 5.1 from the module. Activity 5.1. So we're starting with question 2. So the question is saying find the value of P. So to find the value of P, we are going to use the rule all probabilities add up to 1. So calculating the value of P. So to work out the value of P, we use the formula. We add up all the probabilities, you equate that to 1. So going to the question, that's 0.05. Let me just take down those amounts with 0.05, 0.25, 2p, with p we have 0.1. So we're going to add up all those values and equate to 1. So we are saying that's 0.05 plus 0.25 plus 2p plus p plus 0.1. Then you equate this to 1. It should all be equal to 1. So let's then move 0.05 plus 0.25. So 0.05, we add plus 0.25 plus 0.1. So we've added first those without P. So this will give us, 0.05 plus 0.25 plus 0.1. It will give us 0.4. So we've added those without P, then plus 2P, the like terms without P. 2P plus P, that's 3P. So this is just simple maths, then is equals to 1. Then let's put all the values without P on one side. So 3P is equals to 1. If you cross the equal sign, it becomes minus 0.4. So this becomes 3P is equals to 0.6. So using your maths, you divide by 3 both sides. So your P becomes 0.6 divided by 3. That's 0.2. So that's the value of P. So that's how you work out the P value. So all probability adds up to 1. Any questions regarding that? Please. Okay, silence by default, it means no. So let's move on. So after being able to work out the value of P, the next part is being able to calculate the expectation. In other words, that's the mean or average. So given a probability distribution table like this, working out the expectation or mean or average, you multiply the probability times the value of x. So it's just a matter of you multiplying 0.4 times 100 plus 0.3 times 400, 0.18 times 500. So you do that throughout. What you get is the average. So the mean is the average. So we're going to just do one question combining all the aspects. So after the mean, the next thing is to calculate the variance and the standard deviation. So variance, you square the value of x first, then you multiply the same way that we did here. Remember, we multiplied 100 times 0.4. The only difference, you square the value of x first before you multiply by the probability. So you square the value of x before multiplying with the probability. Then after you have squared, like in this case, you square the value of 0 times 0.25. You square 1 times 0.5. You square 2 times 0.25. After you've done that, what you get is not the variance, but you get EX squared. It's the summation of x squared. To then get the variance, we say the summation of x squared minus the mean squared. So let's actually have a question to demonstrate that. Let's actually have a question to demonstrate that. So let's look at activity. Let's look at activity 5.2. Let's do activity 5.2 together. So for activity 5.2, we are told that we are told that returns in a certain business venture to the nearest 1,000 are known to follow the probability distribution function. So we are given the probability distribution function for returns. So the probability of making a loss of 2,000 is 0.1. The probability of making a loss of 1,000 is 0.1 again. Probability of making no losses or profit, that's the probability of breaking even, where a profit is 0, is 0.2. The probability of making a profit of 1,000 is A, 2,000 0.3, 3,000 is 0.1. So the question then says, what is the value of A? So to work out the value of A, first let me just note down my probability, 0.1, 0.1, 0.2 with A, 0.3, and we have 0.1. So to get the value of A, remember the rule, you add all probabilities and they should give you 1. So we're saying 0.1 plus 0.1 plus 0.2 plus A plus 0.3 plus 0.1. This should give you 1. So if you add up all probabilities, it should give you 1. I'm sure by now it's not something new to you. So let's be fast on that. So that's 0.4 plus 0. So that's 0.4 plus 0.4. So that's 0.8. So 0.8 plus A should give you 1. So from there, we move on. You take everything without A on one side. That's 1 minus 0.8. So the final answer is the value of A is 0.2. Standazile, can you hear me now?
I can hear. Sorry, it was my settings.
Okay. Okay, now let's proceed. So after we've calculated the value of A, the next question is find the probability that the business venture makes a loss. So we want the probability of a loss, probability of making a loss, So the probability of making a loss, you add up the probabilities with a loss. As simple as that. You are adding the probabilities with a loss. What do I mean? So X is the return. So if we're getting a negative return, it's a loss. So we're getting a negative return here. We're getting a negative return here. So the probabilities with a loss, 0.1 and 0.1. So if you're adding the probabilities of a loss, you say 0.1. That's the probability of getting a loss of 2,000. Then plus 0.1 probability of making a loss of 1,000. So overall, the probability of getting a loss is 0.2. Always remember, the answer for probability cannot be greater than 1. So probability ranges from 0 to 1. When you are required to work out probability and you get an answer which is above 1, that's very wrong. Or which is negative below 0, that's wrong. So it must range between 0 and 1. Probability of 0 means it's impossible. Probability of 1 is we are sure it will take place. Then let's move on. The next, the probability to realize profit of at least 2,000. At least 2,000. This now requires a bit of understanding of the term at least. At least means that from 2,000 going upwards. At least give me $10. It's $10 and above. So at least 2,000. It means we are looking at 2,000 or more. So the probabilities of 2,000 or more, it means it's 0.3 and 0.1. So we add that up. So probability of at least 2,000. Of at least 2,000. So at least 2,000, we are adding up 0.3 plus 0.1. So the probability of at least 2,000 is 0.4. That's the probability of getting at least 2,000. That's 0.4. Then we move on. Probability of at least 2,000, we move on. Then find the expected earnings and the standard deviation. The expected earnings is the average earnings. So when we talk about the expected earnings, is the average. So how do we work out the average? So let me just recreate that table here. So we have X, which are the earnings. Then we have negative 2,000. Then we have negative 1,000. Then we have 0. Then we have positive 1,000. We have negative 2,000. Then I think it was up to 3,000, if I'm not mistaken. Then the probability of X is equals to X. We had 0.1 here, if my memory still serves me right. Then we have 0.1 here. Then we had A. We calculated that to be 0.2. Let me just confirm. No, it was 0.2. It was 0, then A, then 0.3, then 0.1. Okay. Still 0.2, 0.3, then 0.1. So now we're no longer putting A, we are putting the value of A that we have calculated. So to calculate the expectation E of X, which is the mean. So to get the expectation, also the mean.
Sorry, sir, when you put the second 2,000, it's negative 2,000, it's supposed to be 2,000 without a negative.
Yeah. Thank you for that. Let's move. So that one is positive. Then, if they say find the expectation, it is the same as find the mean. So how do you work that out? That's where I was saying you square the X first. So you're saying negative 2,000 squared. Sorry, no, the expectation, you just multiply x times a probability. X times probability. So you're just multiplying x times probability. That's calculating the mean. So simplifying that gives us what? Can also be working it aside, please. So it means our average earnings is 800. So our expectation or average, remember, mean is the same as average, is the same as expectation. So our expectation, our mean, or our average is 800. Then let's move on. So after calculating the mean, the expectation, or the average, the next question is saying what? And the standard deviation. So it's not just the mean, we need the mean and the standard deviation. So let's work out the standard deviation. So for the standard deviation, we first of all need, the formula says EX squared minus mean squared. So standard deviation, we first of all need EX squared. Of course, I can put the EX squared here. I can put the EX squared. So I'll just calculate. I'll just say expectation squared. So this is where you first of all square the value of x before you multiply with the probability. So you square the value of x. So for the sake of time, I'll just remember, if you square a negative, it becomes a positive. So you can say 2000 squared. $2,000 squared. That would be a very big number. So 2,000 squared, that would give us 4 million. 2,000 squared, that would be 4 million. You multiply by 0.1. 2,000 squared, that would be 4 million. Multiply by 0.1. You do the same, 1,000 squared, that should be 1 million. So yes, that's a million. So that would be a million. That would be a million times 0.1 plus 0 squared, that still remains 0. Times 0.2 plus, We have worked out 2,000 squared already. That's 4 million times 0.3. Oh, sorry, we have skipped 1,000 again here, which is 1 million times 0.2. Then 4 million times 0.3. Plus 9 million times 0.1. It's quite long. So we then simplify that. So that's 4 million times 0.1 plus 1 million times 0.1 plus 1 million times 0.2 plus 4 million times 0.3 plus 9 million times 0.1. So this then gives us 2,800,000. That's our expectation of x squared. To get the standard deviation, we first need the variance. So having the expectation of x squared, you then come up with the variance. So the variance, you say the expectation of x squared, I'll write in words, expectation of x squared minus the mean squared. Expectation of x squared minus the mean squared. So the expectation of x squared, which is 2,800,000 minus the mean, the 800 squared. If you say 800 squared, that would be 800. That would be 640,000. Then that's our variance. What about the standard deviation? Is the square root of variation. Square root of variance. So the standard deviation is the square root of variance. So the standard deviation is going to be the square root of variance. So that's the square root of our answer. So if we say square root of 216, 1, 2, 3, 4. That's 1. So we can say square root of variance, which will give us 1469. So expect calculation errors there in terms of amounts, but the steps are, because the figures we're dealing with are quite huge, but I hope there wasn't any error there. So now that's how we work out. That's how we work out the standard deviation. So standard deviation, work out the variance. If they had said work out the variance only, you would end here. Like the expectation of x squared minus the mean squared, you get your variance. But the standard deviation is the square root of variance. Then, is the venture likely to be successful? So is the venture likely to be successful? So the probability of making a profit we can compare the probability of making a loss and the probability of making a profit. So the probability of making a loss is 0.1 plus 0. Or we can look at, we've already worked out the probability of making a loss. So if the probability of making a loss is 0.2, it means it's more likely to be successful. So I would say yes, it is likely to be successful. Because the probability of making a profit is so probability of making a profit was from here 0.2, 0.3, 0.1 is that's 5, 0.6. And the average profit is 800. On average, we're expecting to make a profit of 800. So that would be my conclusion on that. Then we now need to move to the probability, binomial distribution. But as you can see, I don't know if you can see my time here is showing that the meeting is about to end. So I want to see what happens after it closes, whether I'll be able to just re-record using the same one or we need to send a new link. So the next thing we now want to look at is the binomial distribution. So the binomial distribution. So for what we've been discussing, any questions so far? From what we have been discussing, any questions so far? Okay, so just a moment.